Is that better? There we go. Okay, well, good morning everybody. It's my great pleasure to be MC this morning and introducing Holger. Holger is, I get the title right, Development Manager for Ministry of Primary Industries in Wellington. His talk is on managing successful software innovation in New Zealand, something I'm personally interested in as I built the Innovation Hub in Christchurch, and I'm very fascinated by the words innovation. So Holger and I have been having a good chat, so it'll be fascinating to hear his take on it and how he goes through that. His background is in software development management with experience in computer graphics, data visualization, connecting new and legacy systems, and complex problem solving. Please welcome Holger.
Good morning. Good to see everyone here, and hopefully we get the feedback under control. You'll have seen all the banner in the main theater on the main stage to the right hand side. We're here to talk outcomes, and the outcome I'd like to talk about is the learnings from research I undertook with Dr. Dave Mason on the School of Information Management at Victoria University 2 years ago. At the time, I got interested what makes successful Kiwi tech companies successful, because more and more stories emerged and hearing about that. And so is there a common theme? And remember Tobias talking about frameworks at the beginning of his keynote, and is there a framework? Is there something to learn from? Do we know something about the boundaries? It's quite a big scope, and so we had to narrow it down. And because my background is in software development, I thought, hey, perfect, new product development, with an emphasis on software development. Let's look into that. And can we find companies that are successful that offer a service that's heavily based on software development and where they develop it in-house? So that narrowed the field. And you know, everyone who's studied sciences, if you will, or if you need to come up with theory, it should do three good things. Describe it, describe the phenomenon, explain it, and then also make some predictions. And as practitioners, we're always interested in the predictions and polish the whole lens of, hey, where is this going? But as Tobias said, hey, it's emerging, it's morphing. So I've broken this into main parts here. The first one is a walkthrough through innovation, how it's been theorized. So there's a big brain dump, big download on some of the key terms, and the understanding kind of I need to build up, so we agree on the terms, the common understanding. I try to make it a bit interactive later on as well, so I try to draw on your experience and how you see it, if it resonates. And then I will dive into actually what we learned from the research and how it went and about the companies. So let's take a look at that. I really like this picture for many reasons, but one is you see incredible high-tech floating above New Zealand and draws the high-tech together with a landscape. If you don't know the picture, we're just to the left of that antenna there. That's Wellington. And also illustrates the whole journey with innovation and how we often don't see it. It's around us, it's influencing us, but it's nothing kind of they can touch, and it's there. And so we can ask ourselves, who put it up there? Who had the idea of the ISS? That's the International Space Station. You see the two astronauts extending the power grid. Where's the person? Well, there isn't a single person. It somehow evolved and emerged, and it's built on many, many steps and many innovations, many ideas, things that had to come together. And we heard this morning collaboration. I mean, see, you can't put this thing up there without collaboration and with organizing it. Same for the mountain bike. Not as high-tech, but anyone know who the inventor of the mountain bike is? It wasn't invented by a single person. There isn't the inventor, like we'd say, like Henry Ford and cars and things like that. It was a group of people who started modifying their bikes, and suddenly it was like, hey, people in the industry looked like, people want this stuff. Let's build it on an industrial scale, and it took 5 years, and then suddenly it became a thing, mountain bikes. So it's really individuals, and it's really sheer luck. So there's something more behind it. And innovation is so embedded in our culture and our language, and lots of buzzwords around and disruptive innovation and things like that, that we have to define a bit more what we understand kind of in the context of the research I undertook, what it means for New Zealand high-tech companies, and how we actually deal with it. If you go back to yesterday when Edwin gave his intro to the conference, and it got tweeted several times, it's like, well, if not for dairy, we would be a third world country. I'm working actually for Ministry for Primary Industries. The ministry is looking after 65% of New Zealand GDP. There's a lot of high tech involved. But in terms of thinking, where you take ideas and how do you take them to market and really build innovation, there's a long way to go. And yes, we need more technology companies, and we need something that is really building for our future. Paul Callahan said a bit differently. I quote him here: "As the global economy changes, innovation will be a key component for the future wealth and prosperity of New Zealand." So it's not a new idea. That's getting picked up over and over again. So how do we manage software companies and new products in New Zealand? And obviously, it's not an easy endeavor. So what influence does complexity have? So if these two key terms, innovation, complexity, how do they click together? And then what we find on the ground later on. So let's begin our walkthrough. With some of the innovation models out there. This is very simplistic. That's kind of classical view. You need the initial idea. You have to convert it into something, intellectual thoughts, tangible. You go through the whole new product process. But then if it's sitting there, it's no use yet. You need to commercialize it and make it able to grow. And so it's not any of these single components that's innovation. It's like the whole thing taken together. It's a very high-level view. And there are lots of people and things involved, so it needs management. Or not. Because maybe what we find when we look at companies, well, it doesn't really need to be managed. People are so good and so self-organized, and because they're agile and they have tools and techniques, it just evolves, and it's fine, and we worry way much about it. However, we pretend that complex projects are predictable, that you actually can put this together, foresee it, plan for it, and do it. But is it? So let's expand this a bit more into our area of technology. It's still this linear framework, and we have here three aspects of innovation. It's like the science and tech base, kind of new stuff that's found out and where you can base things on. Turn it into technological developments, new technologies, and then you take it to market. This whole notion, this whole idea of, hey, let's put more into R&D, get government to spend on R&D. The rest will follow. It's very much based on this. And it seems logical, One end in, you build on it, find the right brains, get the right ideas, foster the right environments, and the rest flows on. However, what this model doesn't capture is it's very rigid and stage-gated. When this, then that. Science is primarily viewed as technology-based. Tobias was pointing at the soft stuff this morning, which is actually not soft skills. But in our common understanding, it's like, well, the hard stuff is like, hey, you have your physicists and your computer science people and your managers, and they're kind of all trained and put together, and you have the frameworks and theories, and you make it click together, and this touchy-feely soft stuff is somewhere out there, and yeah, we have to deal with it. But turn it on its head, and where is kind of the human factor in there? It's a bit hard to see, because this model actually doesn't represent it. And in the linear progression, with all these human interactions, you don't see how it actually influences the different blocks and what happens there, because there's a lot happening there. The devil is in the detail. It's often also, despite your best planning and your best intentions, that throws stuff off the track. Parts of the blocks, they're getting better at what they're doing, and it's associated with certain institutions like universities and so on, where you say like, hey, we can't be in your ivory tower, you have to turn it into something tangible. Things like that. So it has an influence, and there are good points in there, but it's very incomplete. And again, I want to draw out the complex interactions between these elements. They're not really represented here. And the other bit is, where's entrepreneurship? Entrepreneur is a term kind of based on the French. It's like someone who runs a business, someone who draws it all together, someone who is not only in the technology, who's not only in the business world, who can actually really put it together and be successful at it. And this doesn't really show this well. I mean, there might be an assumption that, yeah, there's an entrepreneur all over this, but it doesn't really show it and doesn't help you as a framework. I said kind of like these models, I mean, they're not kind of as the truth, but they help you analyze. So this is so much on the linear model. Let's think about a little bit how products emerge in reality. So often innovation emerges in the cracks between creativity and the managed process. If there's too much efficiency, and yesterday we had a couple of talks where like, how much throughput can you generate? How much can you squeeze out? Remember kind of 5 people on the stage throwing tennis balls? How much can you load into the system before they start dropping the balls? You want to be efficient, but on the other hand, you need the creativity, because without that, that's like in the system, you can't come up with new stuff. You need experimentation. There's a big point in here that this pull needs to be balanced. And it's really hard. And there's a lot of uncertainty in it. Because how do you know how much you put into your system, what your teams can manage? You're not overloading them, but then how much is too little? And this uncertainty is something we really want to see what helps you, what can you manage. And often, if you think about it, the target is clear. You have your customer walking in saying, hey, we want a new website and it should do this and this and this. All right. So it becomes about, okay, what technology and how do we implement it? Do we have the people who know what they're doing? And so you know the commercial opportunity, but you need to manage the development and the engineering. What if you don't know the target where you want to get to, and if you don't know how to get there? It's blue sky research. It's like you have to experiment and you come up with something where you say, oh, actually we could turn into that. Very much the field of big organizations and universities at that stage. I think how there's a movement of open innovation where suddenly organizations thinking, we want to keep our IP. We don't want anyone to steal stuff. But on the other hand, isn't there a bigger gain if we actually share stuff? Some ideas to open source software, but taken to the idea of innovation. And the idea is that you stay efficient, but you create room also for your creativity. So let's talk about this briefly, because I think for anyone in the room here, this is quite familiar and there's easy agreement. I just want to highlight that new product development has certain traits, and software policies certain traits. Software is always new product development because it's hardly a mass manufacturing problem. It's very much based on what you need kind of out there. But then to put it together, it's often complex. And some people, when they were talking to me, said like, oh, it's like Lego, you know. It's all these lovely frameworks, and you just put it together, and you just need knowledgeable people to click it together. That's true for your first release, and from there on, you run into trouble. It's never easy. And once you put something in front of people, they will change their minds. And it's one of the pervasive topics in Agile in our movements, like, yep, we don't want to be rigid, but you can't spec it out up front. And so you can't really make it conveyor belt mass manufacturing problems. And it still follows in a lot of the models this linear path that you see at the bottom. You have ideas, do the research development, and bang, you put it out there. So let's dive a bit deeper. New product development and innovative software. Because we have all these lovely frameworks around things how we want to deal with slaying the complexity and the typical challenges that come up. So if you think about your different methods, pair programming, XP, Scrum, what you put in around that, you give your teams a framework. And that helps you manage process developer teams, communication. One of the talks I really loved this was the three amigos, how you make them align and work together. And then how do you inject at the same time experimentation. Some companies do like FedEx days. We say like, okay, we set time aside. So they time box it. Say, hey, this is your space. There you can go and experiment while you're following the frameworks. But still, you have to deal with all these kinds of complexity emerging from out of that. And then the question is, how do you manage it and how does it affect the process? So I wanted to talk to New Zealand companies about that. And the challenges they face. The typical ones are, if you see on the bottom right-hand side, software is malleable, we know that, it's intangible. There are a few barriers to setting up business, especially these days where even stuff that's quite resource hungry. Think of movies, visual effects. You need that big render farm. If you go out to Miramar, to Verta Digital, they have a big building there, many 10,000 cores. This stuff is becoming available in the cloud. So suddenly, you take your expertise and say, well, I can put this together with my two mates, and when we need it to render pictures in high resolution, I have it on demand. It goes back to this innovation model. It's like, hey, technology enables you something that you couldn't do before as a business model in certain capabilities. And with software, it is a different base to other manufacturing processes and has a huge impact. Consumers play a totally different role. And one that I particularly love is the impact a single programmer can have. Steve McConnell did a fair bit of research on that, and it's disputed how true these things is. Like, can a particular programmer be 10 times more effective and things like that? But there are some ideas around there. What the challenges? Would you find this in any other field like this? Or is it rather typical? I would argue it's very typical to software. And how do you manage it? Think of the complexity. How you would define that? What is complexity for you? I pick on you, Siobhan.
What about a significant number of unknowns?
Significant number of unknowns. Any other ideas? Complexity. If you measure it, if you want to measure it, if you want to make it concrete, if you want to build a model around it, how do you measure it? We talked about innovation, the complexity. How do you put a yardstick against it?
But there's two models, isn't it? There's a model of complicatedness where there's lots of inputs and it's a difficult way to understand how the inputs relate to outputs, but it's predictable. And there's another one where there's no way to understand the connection between inputs and outputs necessarily. So there's two different aspects of that.
Yeah, so number of inputs, connection between inputs and outputs. How many permutations do you have between this? Who has heard of Elliot Jacques? Who has not heard of the midlife crisis? Well, you actually heard of Elliot Jacques because he defined it. He's an organizational psychologist, and he looked very much into humans, how they deal with tasks, how much they can hold at the time, how they deal with complexity. And he wanted to measure it because it was all very much like, hey, if you can't put a yardstick against it, it's really hard to come up with a framework with theories. So he came up with the concept of time span, because all human activities are events, and events have a duration. And if you look at the bottom right, short time span, long time span, number of decisions, number of inputs, only a couple, many influencing factors. The unknown factors, what you had there, a bit more like the tactical. I know how to do this. I've done this before. Think of story points. How do you find story points? You agree with your team, hey, this is our baseline. This is how much it takes to build initial web page. And we measure everything against it. We don't do it absolute. We don't say like, hey, it's on so many days. We say it in terms of relative. I know how to do these things. Now I have to estimate, is it 5 times more, 10 times more, and how much does it draw out? How quick do you get feedback? Think of your Scrum. Every 2 weeks, retrospective, but then in the daily stand-up. So there's very quick feedback, then there's a longer feedback. But then, what are you doing? You're building a product, you put it out to market, and you don't know early on kind of what's going to happen. It's coming back to you. That's the market response. And it might be a year down the track. You're trying to convince people to put more money into it, more resources, keep your team on it. But you don't have the ultimate response yet. And there's more ambiguity in it. And so it's more complex. So using that to measure it, I would like to start to introduce a model we used in the research, which now draws together this whole idea of time span and complexity.
So would that mean that kind of sleeping is more complex than programming? Because when I program for 2 hours. When I sleep for 8. How that...
In terms of programming, what is kind of the task? Because you're comparing 2 different tasks. So how do you compare?
Yeah, but that's what I'm saying. So when you want to measure complexity, you're comparing 2 different tasks. So I just want to understand this right. So how would you model this? How does this kind of relate to measuring 2 different tasks and comparing relative complexity? Because sometimes, it's menial, but it takes long to do. Manual testing takes a long time to do. It's not necessarily complex. Automated testing is horribly more complex, but it takes a shorter time to do. So I might be misunderstanding this. That's why I'm raising the question.
It's the combination of all these factors. But if you take, for example, testing. At the beginning of your test cycle, how confident are you about the outcome at the end of completion of that task? So it's not the absolute time that determines it alone. It's also your confidence in terms of how much can you predict the outcome of that task at the end. And the more factors are at play, the more you increase the complexity. And the longer you draw it out, because if you compare your testing cycle for kind of your next iteration to your overall testing for in a year's time. Take another example in terms.
Confidence in outcomes is that confidence in outcomes is the complexity that you're talking about.
Yeah, or the amount of things that are influencing these outcomes. How much ambiguity are you introducing over time? Think of it, how much can you slay with skill or mastery at some point and increase your prediction by that versus despite all your mastery, how little you can influence that side. Take the job of your chief technology officer and having to make a decision around what technology platform are we going to build our business on. There's a lot of these things going on in terms of like the number of decisions, the factors that influence, and so on. And the outcome, if it's working for you or not, can't be determined in the short term. Because
I understand it. I was just talking about the sentence here that the time span is used to measure the complexity. That's what I misunderstood.
Maybe it becomes a little bit clearer in how we use this on the next slides. But if not, get back to me. So I want to introduce the model and that we ended up using to actually then analyze the companies we're talking to. And here you have more or less the hard cycle, but it's less linear. It's now influencing each other. Where you say like, okay, how's technology change happening? And how's that influencing, again, what can be done on the left-hand side in terms of science? Can you do exploration that wasn't there before? And how does that influence product development? An example I was thinking of is Magritech, which is a scientific instrument company here in Wellington and founded by Sir Paul Callahan. And MRIs, the magnetic resonance imaging machines in hospitals, big machines, they're not very portable. But Massey University wanted to do research in Antarctica, and they said, well, we can't really take an MRI down there. But they put their heads together, and they came actually up with a solution where they made it desktop device, most transportable. And that was purely done to increase the scientific research. And it was only possible because of recent technology changes. They worked with a university in Germany on that one. So after that, it was like, well, this is actually useful. We could actually develop a product out of that. And then they went all the way and commercialized it. This is very much also pointing back to the very first model with the 3 blocks, pump a lot into our R&D, and the rest will follow on. However, there's again the soft stuff. And how do markets change? How can you predict that? Are there theories around there that help you? What kind of research is done here? I mean, physicists or biologists and so on, they're not really concerned with that. It's like social sciences. And a lot of analytics, and also with kind of what's in play with social networking, and we're suddenly analytics and looking scientifically beyond kind of what's going on is influencing kind of what is happening in the market. And that, in turn, influences the product development. So if we're taking all these aspects together, now deep breath, because that's kind of the model we're landing on, meaning up with this. This model was put in place by Berkeley researchers in the Netherlands. And they say like, hey, you have here your technology, your product, your market, and your science. And it's not linear relationship. It's actually all these influence each other in feedback cycles. So you have between technology and product creation. That's kind of a lot of the engineering stuff going on there. Think of cloud services. We create a product that's based on existing technology. If you think about science influencing technology, it's like MP3, the algorithm that was kind of invented by mathematicians. They weren't sitting there and said like, hey, it would be really cool to have an iPod and Steve Jobs is going to take it to market. They were actually looking into solutions on how to compress audio further. wasn't really meant for music and passing it around that way. But that's what it landed on. And technology was built around it, and a lot of products emerged from that, which influenced markets. And there are enough stories around on how kind of certain product lines died and what happened there. Social insight, data mining, market research, kind of was the bottom left. Things influence each other there. And at the middle, you have this idea of the entrepreneurship. Because if you're really strong in one of these, you might not complete your whole cycle of innovation. You might not go all the way. So you need someone actually drawing it together. It doesn't have to be a single person. It could be a team. It could be an organization. This idea of entrepreneurship is kind of you spin the poles and you be aware kind of what's happening there. And I was curious to hear kind of after giving you examples and kind of what's going on there, how this resonates, and if you just throw out other ideas, kind of what is happening in these different poles, like recently. Especially in New Zealand. Maybe think of your own companies or organizations you work for. So the key thing to remember is kind of these 4 poles, how they influence each other. And we're taking these, technology, product, market, science, and see what is the company dealing with? How complex is it for them? How much science complexity, how much unknowns they have there? How soon can they tell about the outcomes? It's stuff that's already available in terms of like technology, and you're just putting together into a product that hasn't been there like before. Or is it actually a thing, and is it a big theme really for New Zealand, kind of how you interact with the market, kind of transitions there? Is this being bottom of the world really a big thing, or does it turn out differently? So let's look. Yeah, or they're aware of kind of what's happening in that field. So the question was like, hey, not many companies will have like the complexity on the scientific side, on the scientific pole. So are they all falling into like market transitions? Is all the complexity in the New Zealand companies kind of like down here? Macritech was the example I mentioned, where it actually came out of scientific exploration and advancements there, and they turned it into technology. Metakina is another Wellington-based company. They do breast cancer screening and prediction. And that is also based on science out of Oxford, but they were aware of it. They listened to stuff, and they found a company on that. And it very much influences what happens in the field there to what they can do with their product. So it's not that you're completely separated from that, or that something that's coming out of that pole isn't influencing what you do with your technology. Think about storage. If someone really cracks it and said like, hey, we can do storage differently, we make it much cheaper, and the size of a sugar cube can now hold 20,000 terabytes. Quite a game changer, and obviously the scientific base that discovered it and say, well, we don't know how to actually make it now work as a product and sell it. That will be exploited pretty fast. So I was lucky enough to find companies and people willing to talk to me. Because this research wasn't done by surveys. I didn't send out a survey and say like, hey, rate yourself on how complex you think, or how much complexity you think you have in the technology pole or in your market and things like that. So I sat down with CTOs, with product managers, And people who were on these boundaries between development, delivery, product creation, and get it out there, and had insight into kind of all the complexities around it. It's quite a mix in terms of like size of companies, who their customers are, and the kind of business they're doing. And it's only a small sample. So I had to take a stab at kind of what themes are emerging, what's coming out of here. And after the interviews, we sat down for an hour, 1.5, I had this whole transcript. It was more or less a brain dump of the thoughts and pointers of what's going on, and had to disseminate it, what was in there. And so I started to put, depending on what I was told, onto these 4 poles from the model. Said, oh yeah, okay. Magritech, for example. I mean, Magritech wasn't a company in the survey, so I can kind of name them. But they have lots of complexity, unsolved stuff in the science. They really have to deal with a lot of unknowns there. They can't predict the outcomes in the short term. So their time span in that pole is quite long. They have high complexity. Might be kind of like to market. They even don't know who would buy that stuff yet. They had a need for it, but they haven't really explored what's going on there. On the other hand, technology, they need to put it together and to make it a product that's pretty clear cut, because they know what's the problem to solve. Take a big MRI machine, make it small, take it to Antarctica or wherever you want it, and do your measurements. So that's a very coarse measure, and if you get 2 ticks, you have a 2-level company, 3 ticks, 3-level company, and then you can compare. This gives you a snapshot in time, because obviously over time it will change for every company. But you can compare. It's like, hey, high complexity, low complexity. And then how does that influence how they run their delivery, how they manage innovation and complexity? Does it mean that they have big differences? But it's coarse. So it was needed to actually take it a notch finer and say, well, even if you have 2 companies that they have the same level of complexity, they're both a 2-level complexity company. You see kind of like here, 1, 2, 1, 2. There's still difference in the other pole. We say, hey, they have no problem kind of with the product itself, productize it, and they just might have a problem to kind of take it to market and get it out to people that they say they love it. Yeah.
So can you just explain what the 3 boxes are?
This is more or less, instead of a tick, the scale of, okay, here you're high complex, medium, low, and just fine graining what I had in the previous slide. Instead of saying, like, yep, you're complex or not, black and white, just to see kind of how companies pan out. For example, do the sample companies we have, do they have all ticks here? They all actually strike really big complexity because they don't know how to take to market. They don't know how to get their head into the science or not. Who knows? So this is a more fine-grained measure. And just to illustrate that even if you're getting the big ticks in 2 areas, it doesn't mean you're really the same. The science example is we're more or less looking into the cutting edge stuff. We're actually not quite sure how it falls yet and how it influences it. And we can't really predict the outcome in terms of how it influences technology. Example, not in software, but for example, in Austria, they were researching solar cells. And chlorophyll extracted from leaves, if you can create a film, put it on glass, and tint it with this extracted chlorophyll, it can act as a solar cell. So they still haven't cracked it in terms of how to make this efficient and how this actually kind of works if they kind of reach level of, if we turn this into technology, is it efficient enough? Right now we can prove it works, but only at that level. And we have to do more science. We have to put more things together to actually get it to a level that we take it and influence the next pole and turn it into technology. So you have a lot of research out there that isn't ready kind of to influence this next pole.
That measure on those companies that science go on all that. How, I mean, if you were going to a normal software company, what sort of questions would you be asking to gauge that? You know, do you go do literature research, or do you go and talk to universities? How do you gauge that from company?
That is a question kind of for the entrepreneurship. How do you collaborate? How you actually then talk to people in that domain of science and that can influence kind of what you're doing? Because overall, it becomes about your product. And if you're, for example, in the business of breast cancer screening, it might be you're talking to mathematicians and statistical models, because what you're getting actually out of the probes is a very fuzzy signal. And you need the science to actually turn the signal into something more usable. If you're watching digital TV, kind of there's a compression behind this, and no one thinks of it when I'm watching TV and doing this, this is discrete cosine transformation, and the science behind it. But to do certain things that you want to do in your technology product, you need kind of advancements there. And if you really depend on that, where you say like, well, because we're in this line of business for medical imaging, we can't ignore this pole and kind of influences it has on you. You also might be sideswiped because someone comes out of that area and says like, hey, what are you doing here? It's becoming obsolete. So it came down to the idea that if you use these fine-grained measures and you match up the companies, you find matching management styles, matching ways of dealing with innovation. And if they're not matching, it'll be different. So this is the course mapping of the 8 companies. And you see there is actually quite a variety. It's not that, hey, because you're in New Zealand and because of your geographical location and because you're all in software, it's all the same story for you. Again, there's way more detail behind here, but then I would talk for another hour. And I just want to highlight that there's some companies in here, they're pretty high, even on the course level, kind of with 3. The only thing they're low in science. But in terms of like technology, the product, and the market, they're unknowns, and it's really hard to put together in terms of their timelines. I started to pair them up and said, okay, if this all holds, let's pick the ones that have similar complexities. And here, it turns out that the science complexity, and for example, someone in medical imaging business or someone in fraud analysis, again, based on algorithms, more or less BI extended into kind of what can science and scientists, mathematicians, statistics kind of deliver to you to enhance what you're doing with your technology. How do you troll through big data sets? How do you analyze it and how you bring it down? Lots of research going on there. So that'll influence kind of what you can do with your product. And turns out these complexity comes, they're all spin-offs of academic research. So it's coming out of universities. So there seems to be something in the idea of, well, okay, if you have these people together thinking about stuff and having the freedom come up with these boundaries and edge cases, we can take it further. And it was interesting to note that it was really a specification-driven development process, which was also driven by, because the stuff had to be certified and taken in certain steps. here's two companies paired up with product complexity. They can't really predict kind of their roadmap with a certain amount of certainty. There's a high complexity in there, and they constantly try to extend, optimize, exploit kind of what's in there, and they can't stick the plan. Typical Agile problem. And they had to be very flexible. They had to be very responsive, and so it was a very good match in terms of how they dealt with us and how it matched up. Here's some where it's very dissimilar, and where it also shows that they are opposing in terms of how they deal with it. Constant experimentation versus stage-gated process, and the different challenges they had. So, in the end, there were these emerging themes, and for us in the room, some of that stuff isn't really new, because being part of the Agile community, you hear a lot about these things and kind of how its influences, and we're convinced about what's in there. You have to negotiate with the customer. You have to kind of involve them in some form. It doesn't always mean kind of like directly, but you have to have an idea about it. Iterations play a role. And none of these companies, even if they were stage-gated, didn't have any iterations. They were all going through iterations. There was a difference in kind of like how long and how they were treated. Teams, there was a big overlap in terms of the size of the teams. And even with bigger research projects and companies kind of heavily based on research, they didn't grow their teams big. And also in terms of the direction, how they were goal-directed. And in terms of the slack, going back to this pull between being optimized and being creative, they all had their ways of creating the slack in some form. And looking across it in terms of if you're an established company, startup, something else, there was something in there in terms of the efficiency, well-defined products versus kind of the creativity and openness and how they were dealing with that. Startups kind of chasing the emerging markets and how they treat intervention with the team and networking. And again, this idea for startups that they collaborate, and as you mentioned in the intro, kind of in Christchurch, this collaboration hub, having these sitting together, being in the same vicinity, was way more comfortable than kind of for the established players. They say, no, we keep it to ourselves. We have an edge. We want to keep it close to our chest. But it's really hard for New Zealand companies kind of to maintain that because we don't have such a big footprint. And as Edwin said in his keynote, we have to grow it. We have to actually get better. And we have to get better in the chasing of emerging markets and networking together and learn from that. And yeah, with the outliers, it was kind of like, hey, there's one layer removed. You're not really directly with your customer, and it's like kind of this middle tier, and there are needs around that. So altogether, what I hope you got out of this is insight into innovation, some models, how you can view management of innovation, look at the Cyclical Innovation Model and how it's cyclic and not linear, and how each pole influences each other, and how it needs someone or a team group in the middle, kind of keeping an eye out. And measure for complexity. Thank you very much.
Thanks, Holger. We're pretty much okay for a couple of questions for time, so if anybody has a question, please raise your hand and I'm sure Holger can. address that.
If I may, I just want to answer the question the gentleman from complex systems, also known as a chaotic system. Any isolated things that are constant or variable, and any static time does not represent any probability and change in nature. So that's why we need a time span to substantially pattern recognition of that complex system. So that makes time span really important for complex systems.
You know, since it's not important, just not, I didn't understand why is it the only measure.
Oh, certainly it's not the only measure. Sorry, I mean, if that's kind of how it came across, absolutely not. But for the...
I probably misunderstood it.
No. It was here kind of for the research, kind of to find out and to be able to disseminate it, kind of what is a measure, because complexity is so vast and kind of it can have so many different meanings. It's like kind of that's the definition we went with, and that's how we took the interviews apart and said, all right, from what you're saying, I hear you have a lot of complexity in your technology, because that stuff you're going to use and you're building on, it isn't quite there yet.
So maybe I missed the point of the relationship between complexity and innovation. Are you saying that a more complex business with all those factors reduces their ability to be innovative because they don't have the room to move because it's so complicated, or were you not trying to draw any relationship between the two?
No, I wasn't trying to draw a relationship. It was more innovation is hardly a linear process. There are at least 4 poles in this model influencing each other. And think about your own business or your own project. Have you ever thought about the non-technology pole? I mean, with this development team, you're very much into like, how do we create the technology? And then Agile kind of pulls in this product owner and, hey, work with your customers and what they really need, feedback loops, and so on. They draw this other stuff. You can see the bottom side more as kind of the soft stuff, and the top side more as the hard stuff. Hard science, technology, and so on. And so it was more, if you step back and think about it, have I thought about all the complexities I actually have to deal with? And then if I rate myself on it, so like, oh, actually, hang on, there's something coming in. I said visual effects where you need big organizations, big providers to actually deliver on imagery. It's changing. You really literally can put your stuff in the cloud, churn away, and get it back the day after. If you're a little architecture bureau and want to do a walkthrough, so you can do this because the technology doesn't keep you back anymore because it has changed. Well, if little architects now can do that, they can play in a different field that changed their markets, what customers do, and suddenly that influences other things as well. And so think about the complexity in your environment and how would you see it, how would you rate yourself?
What do you do with that? So, okay, complicated.
Think about how you deal with it and what do you put in place, because on one hand you want to be efficient. That's the whole thing. Let's get as many tennis balls efficiently into the group as we can. But then what would you like to put into place to actually also get the creativity? And if you have complexity and you actually can't really on the times when predict how we're going, how this is panning out, you better put something in place and think about it. And there are many ways to go about it. So this doesn't tell you kind of what. It's just a lens on how you pick it apart and say, well, actually, we haven't thought about this bit. Or we better talk to these people, these groups. Or maybe we should be a bit more open. We should collaborate on certain things and what's there. If you sit in Christchurch, have you ever engaged with the Epic Hub or not? Why not? You think because you don't have any of these complexities and you've swayed and played close to your chest. So it comes down to what you make of your analysis.
One thing I'd just say with that, which I quite like, is I often get asked how do we prioritize projects, and what this could help you do is use great projects against it and go, well, this one has loads of unknowns on the technology, science, market. How valuable is it? You know, it sort of always gives an idea of risk as an entrepreneur. You start thinking, okay, I'm going to take this risk, I'm going to go with the easy one now. I think we're pretty much done for time, guys, but thank you very much again, Holger. And I think if you want to have a chat with him over morning tea in the Oceana room, you're very good. Thank you again.
Thank you very much. Cheers.